Good afternoon, everyone. So, in continuation with previous session, so we have Hdfs Key Points. So, based on the Hadoop version, so the key points is like based on the Hadoop version. So, we are going to use it default block size. Okay. So, what is this 1x, 2x, 3x? Let us see. So, Hadoop is started with 1.0 first. Let me open. So, Hadoop is started with 1.0 version. Then they started 1.0.1, then 1.2, 1.1, then 1.2, then 1.3, then 1.4, like that 1.10. Okay, so instead of calling these all 1x, 2x, 1.5, 1.6, 1.7, 1.8, 1.9, so 1.10. So like that, instead of calling these everything, so we'll call it as Hadoop 1x. Hadoop 1x. Instead of calling 1 by 1, 1.0, 1.1, so we will call it as 1x. Similarly, Hadoop 2.0 also. Hadoop started with 2.0, 2.1, 2.2, 2.2, 2.3, 2.4, 2.5, and we have subversion also 2.5.2, 2.6, 2.6.1, 2.6.2, 2.6.3, 2.6.4, 2.6.5 also. We have something like subversions also available in 2. Then 2.7, then here 2.7.1, 2.7.2, 2.7.3, something like subversions also available. Okay. So similarly 2.8, 2.9, then 2.10. Instead of 2.10, these all are, they will call it as 2x. Hadoop 2x. These all versions, instead of calling separate, so these all versions will call it as 2x. Okay. Similarly, Hadoop 3 also available. So Hadoop 3 currently started with Hadoop 3.0, then 3.1, currently 3.1.1 or 2 is running. So these all are called, like we'll call it as Hadoop 1x, 2x, 3x. Okay. So each and every version we have separate block size. Okay. So what is the block size? Block size for Hadoop 1x, 64 MB default block size. When it comes to the Hadoop 2, default block size 128 MB. Similarly, if you have written Hadoop 3x, block size 256 MB block size. That is what here. So based on your Hadoop version, so we have, if you are using default block size in 128 MB, 64 MB Hadoop 1x onwards, Hadoop 2x 128 MB, Hadoop 3x 256 MB block size, default block size for Hadoop. Okay, so when you copy a file from outside to Hadoop, so based on your Hadoop version, it will be divided into blocks, pieces. It will be divided into pieces called blocks, and each block is replicated 3 times. Right? For example, block 1, 1 copy, second copy, third copy. Block 2, first copy, second copy, third copy. Block 4, first copy, second copy, third copy. Like this, each and every block will be replicated 3 times into available data nodes in the cluster. Okay, and block is never replicated on the same node. For example, block 1 first copy, second copy will not be on same data node. It's always on different data nodes. Okay, so that is the main important point, because what is the reason? If this node goes down, only one copy will be loose. So if you are copying same copy, block 1, all 3 copies in one node, if one node goes down, that node, all copies will lose it, will completely lose all the block information, block data. Right? So to avoid that, they have designed architecture is each and every block, each copy in a block in a data nodes will stored in separate data nodes inside the Hadoop cluster. That is what Hadoop designed. Okay, so let us see. So key points are Hadoop 1x 64 MB, Hadoop 2x 128 MB, Hadoop 3x 256 MB, and every file is whatever you copied the file from outside to Hadoop. So every file is split into blocks. Every block is replicated 3 times by default, and block is never replicated on the same node. Okay, so that is key points of the HDFS. Then features of the HDFS. So if you're, what is the reason of, like, what are the features available in if you're using Hadoop HDFS? So high performance, because what is the, how it will be high performance? So if you are using multi-distributed environment, right? So read and write from the distributed environment, file reading and writing is fast because multiple resources are available. Okay, so reading and writing is very fast compared to single machine. Okay, that is high performance. Faulty tolerance. Faulty tolerance is nothing but, so we are loading 3 copies of data, right? Each block is replicated 3 copies. If 1 copy lose, so we have 2 more copies available. If 2 copies lose, some problem with the nodes, we have 1 more copy available. But meantime, we discussed earlier what name node duty. So name node duty is always, it will maintain what is the replication factor always. It will monitor the replication factor, and if it is any replication factor reduced, I mean under replicated, then it is trying to re-replicate into the available data nodes. That is the name node duty. But what is the time? Name node will wait 10 minutes 30 seconds. For example, if any data node goes down, so name node will wait 10 minutes 30 seconds, and then if the data node is still down, then name node is trying to re-replicate the missing data from the cluster or whatever the data available on the failed data node. That data node data trying to re-replicate into any available data nodes in the cluster. So that's the way it is maintaining always all the 3 copies of data. So there may be no more data loss. That is called faulty tolerance. And relatively simple and centralized management. So simple architecture, master slave. So one master, multiple slaves. It's called a master slave architecture. Right? And security. So we have default security available in ACLs in the Hadoop level. So whatever the required, according to, like, including, we have Linux is a security is available, Linux level, local file system. So apart from that, so we have ACL's default securities available in Hadoop. So we have strong security mechanisms are available. So when we are going for discussion of security, so we'll discuss. We have a strong security method, Kerberos. Okay, so let us wait. So we have strong security method using Kerberos also, where it can support, and also optimized for distributed data processing. So what is this means? Data locality. So for example, if you are trying to process your data, so it will wait, it will check where the nearest data available on the nearest point. So then it is going to there, and it will try to process the data there itself. That is data localization. So it will go to the task wherever the data is available on the data nodes. It will go to and run there itself. scalability. So always scalability is high availability of scalability. So this is the features of HDFS. Okay, so then let us go to the next topic. So we have seen in the previous session metadata. Where it is storing a metadata? Name node, right? So metadata is stored on name node. But how it is maintained on the name node metadata? Metadata maintained on the name node, how it is? Like, is there any form of files or is there any different way how it is maintaining? So metadata maintained in name node is, there are two main files. One is fs image and another one is edits. So it means when I can say, if I can say metadata about the data, that is metadata consists of two files. One file is fs image and another file is edits. Okay, so what is fs image, what is edits, we'll see detailed. So fs image, the entire file system namespace including the mapping of blocks to files and file system properties is stored in a file called fs image. So name node keeps an image of the entire file system namespace in memory. So fs image is persisted to disk. So it is stored on the disk. Okay, so fs image, what is fs image? The entire file system namespace. For example, if you installed a cluster and if you loaded some data, so after you installed the cluster and you started the cluster and you loaded some data, the data entire file system namespace including the mapping of the blocks, files, everything is called as a storing, and properties will be stored in a file called fs image. So it means when you started the fresh cluster, new cluster, the file system information and the files, everything will be stored in a file called fs image. Okay, then later what about edits? Edits is a file, okay, so where the latest transactions, so after the cluster is started, okay, the cluster is started means what is, you have loaded some data from the first when you started the cluster, then what is our operations, like what is the operations, regular operations, like people are generally loading the data and reading and executing some programs, right? So those are called as operations, day-to-day operations, general operations. So that general operations records, general operations, logs, general operations, records and log files will be rotated. What are the operations, general operations, day-to-day operations going on? There is a record will be created each and every operation. For example, if one user is trying to read the data, some file, that will be a one operation, right? User operation, end user operation. That operation, it is stored in a file called edits. Record will be created. That is look like a audit. I can say log file will be generated. That log location where the storing of the logs in a file called edits. Okay. So each and every transaction records are storing in a file called edits. So rather than modifying the existing fs image every time, the name node instead of records the new transactions in the edit log for client operations. If the name node crashes, it can restore state by first loading the fs image, then replying all the transactions. Okay, so and also it is called as edits. In the edit log, to catch up the most recent state of the file system. fs image and edits are physical files stored on the local file system. Okay, so this is maintaining in the fs image and edits. So both are, so we can say it as metadata. So metadata is maintained in a file called two files, fs image and edits. Okay, so let us move to the next slide. So types of metadata. What type of, so we have metadata, but what includes, what and all it is available in the metadata? So list of files, right? What are, for example, if you have not a single file in a cluster, multiple files, it means list of files. It means number, how many number of files. So it is maintaining, that is also part of metadata. And list of blocks for each file. You have multiple files and multiple sizes, right? Not all same size for each file, different size. Each file will be divided into blocks. What are those blocks for each file? How many blocks? list of blocks for each file, file attributes like owner, permission, timestamp, size, replication, array of blocks, right? So everything, and also list of data nodes for each block stored on. It means for block, for example, one block, if it is a 2 to 3 blocks, one file, so each block will be replicated three data nodes, 3 copies. So what and all data nodes it is storing. That information we'll call it as also types of metadata. You can see here in the file you have metadata, you have data nodes, block 1, right, block 2, 3, something like that. So all the blocks file metadata is storing on the here, and similarly these we'll call it as this is fs image. Inside the metadata fs image file storing entire file system and file system properties. Then these are the logs, edits file, recent operations, latest operations going on, which is storing in a file called edits. So after some time the fs image and edits will be merged and generate a new fs image file that we will discuss when coming. Okay, so this is fs image storing in a file. Okay, so entire file system metadata, and this is edits logs. Okay, so this is, let us go to the next one. And what is block report? So every time data node starts restart, it advertisement the blocks, whatever it is stored, whatever it is blocks is having, the blocks block report, data node will send a report to name node. For example, if data node is having 100 blocks, okay, so for example when you restarted, for example some of the reason you restarted the data node, so when you restart, block image will be logical file to the name node. So when you restarted, the logical file will be, link will be deleted. Then when you restarted, the link will be automatically re-established, and the data nodes will send all the whatever the blocks information available to the block report, blocks details, and to the data node will send it to name node. Otherwise name node will not have a information. So every time whenever restarted happened in the data node, so it should send block information, block report. That is called, how many blocks data node is having, that information will send to the name node. That is called block report. So block report bitmap is a logical file which will be created on name node memory. So which will created on name node memory. Then otherwise it will not able to get the fast report on block report. So the mapping between block and data node never persists to disk. It will never store it on a disk. It is on every time on memory. Because if you restarted on the name node or data node, the entire logical file will be deleted and recreated, the logical link. So that is block report. So when block report bitmap will be updated, what are the scenarios block report and bitmap file will be updated? The scenarios like whenever the name node, data node restarted. For example, if some of the reason in the cluster we have restarted name node, data node, that time block report will be updated, right? And there is a default time. So dfs dot block report dot interval milliseconds. So by default 1 hour in Hadoop 1x, 6 hours in Hadoop 2x. Okay, so by every 1 hour in Hadoop 1x, block report will be updated automatically. If you set up the property, this property in Hadoop cluster, or if you set up Hadoop same property in Hadoop 2x, every 6 hours the block report will be updated automatically. Okay, and one more scenario, if name node required on demand, for example name node required, so I want to know the block report on so and so data node, particular data node 10. So we have 100 nodes. So I want block report on data node 15 or data node 20th data node. So on demand request from the name node also, block report will be updated by data node. So those are the scenarios where we can check. And another point is like checkpointing mechanism. So what is meant by checkpointing? So fs image edit logs, what is this? Metadata, right? So we have seen, let me take a paint. So you have fs image, right? So fs image FS image, you have 10,000 records are there. So when you install the cluster, when you started the name node, data node, when you loaded the data, so there is some 10,000 files, 10,000, each and every file will call it as a record. So 10,000 records created in your metadata FS image, right? Then later you are running the client operations in the cluster. So records will be created, right? People are trying to use the cluster, reading, writing. So each and every record that will be created. This is called edits. We know already edits. Edits file, right? Edits file. Okay, so edit records will be created one by one. Okay, so this is edits file. So records will be like increasing. For example, edits, right? So edits will be grown up. So edits will be like grown up like this way. Edits will be grown up, and after some time what will happen? The file will be a big size generated. If edits are keep on growing, if edits means client operations are going on inside the cluster. So it means people are reading, writing, or jobs running. So everything will be running, right? So it means what will happen? The files are increased. The file size is increased. Each and every operation there is a record. These are records. Boxes are called records. Record like, what are the records? What I can say? 1, 2, 3, 4, 5, 6, 7, 8, 9, and like this the records will be creating, and after some time what will happen? If the record is growing like this way, so there will be edits file will be increased the size. So if it is keep on increasing, what will happen? Then again client operations will face some issues. Okay, so there is some certain amount of time, so we need to club these two files. So we need to merge it. We need to merge it. So what is how many records? This is 10,000. For example, this record contains, this edits file contains like 5,000 records. 5,000 operations done, records. Okay, then if you merge it, what is merge? Merge operation. Merging means, what is merging? FS image plus edits. So we are merging edits. Okay, so it will roll it as new FS image. Okay, so how it will be merging? Records will be merging. So what is FS image records? 10,000. Then what is edits records? 5,000. Remaining, if you merge it means what is 15,000. Merging, both records are merging, and generate a new file called, what is the file name? FS image, new FS image. It is both files will be merging and generate a new file called new underscore FS image. Okay, what is the records? How many? 15,000 records of this file. This operation, the merging operation is called checkpointing. Checkpointing operation, and it is performed by secondary name node. This operation is performed by secondary name node in every 1 hour in Hadoop 1x default. Every 1 hour in Hadoop 1x environment, and in every 6 hours in Hadoop 2x environment onwards. Okay, so this is called checkpointing operation. Okay, so this is called checkpointing operation. Checkpointing operation, what will happen after the checkpointing operation done? So after the checkpointing operation is done, once the checkpointing operation means merging of these two files, right? FS image plus edits. The merging means checkpointing. Once the checkpointing is done here, so the file will be 0. So it means the file will be starting from 0 records again. So it means the file will be started again 0 records, like this way. Record 1, record 2, record 3. Like this way it is started. So whatever the records available, previous records 5000 will gone, and record starting from 0, that is edits. And once the checkpointing is done, then we have new FS image 15,000. This file will be replaced to FS image. FS image file will be replaced to new FS image. It means what is our new records? This is previous records. Our new records are 15,000. 15,000 records, new records. Right? So new records. Then again operations continue. So this operation every 1 hour by default automatically it will happen checkpointing. The performance, this operation will be done by secondary name node. Okay. So this is called checkpointing operation. This is checkpointing. Let us go to here. What is checkpointing? So checkpointing is a process that takes FS image and edits and combines them into a new FS image. You can see here the FS image, in the FS image some records and edit logs. So combining both will do a checkpointing operation. It means it's merging and rolling a new FS image. And once it is done, checkpointing is done, the edit logs will be 0, starting from 0. So this is record 1, 2, 3, 4. So after checkpointing happened, again it is starting from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, something like 100, 200 transactions. That is called edit logs, right? So after the checkpointing happened, new FS image will be generated. This new FS image will be replaced to FS image. So it means previously 10,000 records here, 5,000 records. It will merge it here. So once it is merged, new FS image 15,000 records, right? Then this will be go to 0. This file will be replaced to here. So it means now FS image is 15,000 records on the latest file. Okay, this operation will be done by secondary name node. Secondary name node is responsible for the operation, checkpointing operation in Hadoop 1x environment. So by every 1 hour automatically this will checkpointing will happen by default time, every 1 hour. So if you want you can change it the time also, but generally the checkpoint time will not be changed, will not change anyone, because they'll follow by default time every 1 hour. Okay, so that is checkpointing operation. Then secondary name node. So we have a secondary name node available in Hadoop 1x, right? What is secondary name node? We'll see. Okay, so secondary name node. Secondary name node is one of the node in Hadoop 1x cluster. Not only 1x, even 2x also there, but 2x we are not going to use it anymore because 2x architecture we have introduced, they introduced a standby name node as well. Okay, so still we have available in Hadoop 2x also, but we are not going to use it generally. So let us discuss secondary name node. It is not a hot standby for the name node. For example, if any of the reason name node goes down, so this will never act as a backup. This will never act as a standby, right? So it is only secondary name node. What is the use of the secondary? To store one copy of metadata. Okay, so one copy is storing in name node. Where the metadata is storing? Metadata is storing in name node's memory. So another copy is storing in name node, secondary name node, right? So okay, so another reason is like, so it is maintaining, it is also doing checkpointing operations. So Hadoop 1x environment, so secondary name node duty is to do the continuous checkpointing operations on every regular time intervals, and it means so every 1 hour this will do the checkpointing operations on regular intervals. So regular intervals is like Hadoop 1x. What is the time? Every 1 hour. So every 1 hour the checkpointing operations will performed by secondary name node in Hadoop 1x environment. You see, and what it will do? So in the process of checkpointing operation, secondary name node will do, it retrieves the FS image and edits from the name node and perform checkpointing operations on regular intervals. The regular intervals are like every 1 hour. And right, and also it maintains the latest copy of FS image as backup of name node metadata. Okay, so that is what Hadoop and 2x it is doing. Okay, so it will do on regular intervals. It maintains the latest copy of FS image and as a backup of name node metadata. So that is secondary name node duty in Hadoop 1x environment. Okay, so let us move to the next one. So checkpointing, how it will happen in the cluster. So checkpointing, so we discussed checkpointing, but how it will happen inside the cluster checkpointing. So in Hadoop 1x, connects to the active name node and pulls the both edits and FS image. So in the diagram, if you see, the checkpointing will be done by secondary name node, right? So secondary name node will connect to the name node like this way, okay, and pull metadata files. What is the metadata files? FS image and edits. Pull it both from here to here, and it will do the checkpointing operation and roll a new FS image file, right? And roll it a new FS image and then maintain one copy here and another copy they'll send it to name node again. It will replace the previous FS image file. So connect to the active name node and pulls both edits and FS image files from active name node to secondary name node, then rolls a new edits.new file. It will roll edits.new file, merge edits and FS image. Merge FS image and push it back to the active master. Okay, so this is done over through HTTP channel using REST API protocols. So that's the way the checkpointing is happening on the cluster, right? Then what about when checkpointing will occur? So what are the scenarios checkpointing will happen? So we know one scenario. What is the scenario? So every 1 hour checkpointing will happen in Hadoop 1x. Similarly, every 6 hours checkpointing will happen in Hadoop 2x environment, right? So that is one scenario you see here, third one. So checkpointing every 60 minutes in Hadoop 1x checkpointing will happen. Then what are the other scenarios? So whenever you restarted the name node, for example, in your cluster, if some problem, if you are facing some problem, okay, so if you restarted the name node, checkpointing will automatically happen. If you restarted the name node, so checkpointing will automatically happen. Then manual checkpointing. Hadoop admins can able to do manual checkpointing using Hadoop space DFS admin - save namespace command. So manual checkpointing will happen automatically. That is also happened. So this is done by Hadoop administrator manually. Okay. The third one is default time, 60 minutes in 1x. So 6 hours in 2x. So the property we need to set up dfs dot name node dot checkpoint dot period time. We need to set up the time. So other one is dfs dot name node dot checkpoint dot transactions. By default 10 lakh transactions. It means 1 million transactions. If it will happen, 1 million transactions happened on the edits file. Okay, automatically checkpointing will occur. So no need to wait. Automatically checkpointing will occur if 10 lakh transactions are done. So each transaction is a cluster operations. Each record is a, we'll call it as transaction. So one more, fs dot checkpoint dot size, file system checkpoint size, if it reaches by default 64 MB in Hadoop 1x. If it reaches 64 MB of the size, checkpoint size, automatically checkpointing will happen. And these are the 5 scenarios where checkpointing will occur automatically if any one scenario met. So in 5, it will not wait for until 5. So if any one scenario reached the expected value, whatever the value mentioned in that pointing or operations or property, right? So automatically checkpointing will happen in Hadoop environment. Okay, so let us see the next one. So note, secondary name node will not have latest copy of fs image if checkpointing is performed by name node. So what is that? If checkpointing is performed by name node, so for example, if you restarted the name node, so checkpointing is performed by name node, right? So that time secondary name node will not have a latest copy. So when they will have, when checkpointing is performed by secondary name node only, they have latest copy. So other than, it will not have a latest copy. So then when they will get the latest copy, when the next interval, when the checkpointing is happened by secondary name node, that time they will get the latest copy. Okay, so then who is the responsible for checkpointing operations? Hdfs without high availability of name node, secondary name node is the checkpointing operations responsible person and responsible, and Hdfs with high availability of name node, standby name node is the responsible for checkpointing operations in Hadoop 1x and 2x parallelly. So Hadoop 1x, Hdfs without high availability. So Hadoop 1x, we don't have a high availability. So we have only one name node. If one name node goes down, we'll see, we have a discussion. So we'll see that. Okay, so then Hdfs without high availability, secondary name node is the checkpointing operations. Hdfs with high availability of name node, standby name node is the checkpointing operations will do. Okay, then let us see. Then the other one is edge node. So what is meant by edge node? Edge node is the interface node between Hadoop cluster and client applications. So can be referred as a gateway or application node. So no Hadoop daemons will be running here. So often used as a staging area for data being transferred into Hadoop cluster. So if you want to transfer the data from your test environment to production environment, where we can use it, edge node as a storage area. We can store it into edge node, transfer. Okay, so in the edge node, so we can, ecosystem tools can be configured here. Okay, so let us see what is edge node. Moreover, so edge node, let me take a picture. So you have a cluster, data nodes, secondary name node, right? So everything is connected with the name node. Right? So everything is connected with name node. Now you have clients. Clients means developers. Developers want to connect Hadoop cluster. How they will connect? Developers want to connect Hadoop cluster. How they will connect? They cannot able to connect directly. They cannot able to connect directly. So it's not possible. But how? How they will connect? Okay. So we have they cannot able to connect. Okay. But now how? It is not possible directly. But how? Now we have a node called edge node. That is also part of the cluster node. Edge node. So this is also part of the cluster node. Okay. So let me make it. So developers will not able to connect directly to the cluster. So in between, so we have edge node. Edge node is a one of the node. Okay. So where clients can able to connect through edge node to the cluster. So it means clients can connect edge node through edge node, they can connect to the cluster. So without edge node, they cannot able to connect. Not only developers, even admins also, without edge node, we cannot able to connect to the cluster. That is the edge node important here. Edge node is like to communication between cluster and end user. So edge node refers to a connection between cluster, Hadoop cluster and end user. So end users will connect to cluster through edge node only. So I can say it as application node or a gateway node, or generally Hadoop terminology we will call it as edge node. So some of the companies they'll make it as application node, management node, something like master node, something like that they'll call it as different names. But general scenario in Hadoop we have edge node. Okay, through edge node only users can submit their requests. Then through edge node it will hit to the cluster. So name node and get the information, all the information whatever they require. So edge nodes are like important in the cluster environment. Okay, so edge node is the interface between Hadoop cluster and client applications. So it means always end users, any the developers or admins, anyone. So we can connect through edge node only to the cluster. If you want to connect a cluster, we need mandatory to log into edge node first. Otherwise, we cannot able to connect. We don't have access. Okay, so can be referred as a gateway node or application node. You can see here we have a name node, secondary name node, data nodes. But client cannot able to connect directly name node. Through edge node only, client can able to connect name node and then get the data. Right? So that is what. So and also in edge node, nothing. There is no data node, name node running. No secondary name node, nothing. So here we can install some ecosystem tools which is used to process our data in Hadoop cluster for the processing layer like Hive, Pig, Scoop, HBase. Those are the tools we can install it. So other than that, nothing. There is no Hadoop daemons. Hadoop daemons means name node, data node, secondary name node, job tracker, task tracker. Nothing will be installed. Okay, so it will install only for ecosystem tools like Hive, Pig, Scoop. Those are tools we can install in edge node. So and also if you want to load the data from your test to production, so we can load the data into edge node. From there we can load it to cluster. Okay, so that is edge node importance. Let us move to the next one. So limitations of Hadoop 1x storage layer. So what are the limitations as of now we have seen? So we have seen, so Hadoop 1x, we have Hadoop name node, one name node, right? Let us get right here. So name node, SNN, secondary name node. Then here I'll write it as DN, data node 1, data node 2, data node 3, data node 4, right? So we have Hadoop 1x. This is Hadoop 1x cluster. Hadoop 1x cluster storage layer. Architecture. Hadoop 1x architecture storage layer. So what is the drawback here? So we have one name node, one master node, right? So if some of the reasons, if this master node goes down, just imagine what will happen. If some of the reason this name node master node, name node or master node goes down, what will happen? We will lose. So the entire cluster will be down. There is no backup for active name node. There is no backup for name node, right? So even secondary name node we have, but that is not working as a name node. That is only storing a backup data, metadata. So that is a single point of failure in storage layer Hadoop 1x environment. If no name node fails, the entire cluster is down. Okay, then other than that, so if one data node fail, one slave fail, what will happen? Nothing will happen. We have other slaves, we can work, right? So, but what about the data available in this node will be replicated after some time into any other available slave nodes. But cluster will not down. Cluster is still up and we can able to process the client operations. Cluster is fine. So meantime, Hadoop administrator will fix the issue on what is the data node down for the reason. They will verify, they will fix the issue. But if main name node goes down, so we don't have any option in Hadoop 1x environment. So if name node goes down, entire cluster will be down, right? So it means there is no backup name node available in Hadoop 1x environment. Okay, but we have still secondary name node is available that is storing metadata backup, not working look like as a name node. It is not look like working as an actual name node, right? That is storing purpose. It's look like a hard disk. I can say it's look like a hard disk where we can use it for metadata storing, saving. Okay, so that is the single point of failure in name node. So name node, single point of failure. Secondary name node never act as a name node in case of name node failure, right? So what will happen if name node fails? Manual intervention is required in case of name node failure. So what is manual? As a Hadoop administrator, role is required here. So Hadoop administrator manually configure the one more new node and they need to start the cluster again. So it will take a lot of time. That is also a disadvantage. And also, if name node goes down, so we have only one copy of metadata available for entire cluster, right? If name node crashes, where we can get the metadata? For example, here, if we have metadata here, metadata, right? Similarly, one copy is storing here after the checkpointing of every interval, metadata, right? So we have two copies of metadata now. So what will happen if this copy, this entire copy down, name node down, so this copy also will lose. Then we have only one more copy of metadata available. So some problem with this also down, so we will lose entire metadata. Then the data, if even cluster data is available also, no use. If no metadata, how can we connect with files and all? We cannot able to communicate with the files, right? So that is the reason. So here, if name node goes down, what will the scenario? So we have only one copy of metadata available entire cluster. That is also one of the drawback in Hadoop 1x. So it means chances of losing data if checkpointing is not happened. If checkpointing is not happened, what we'll do? We will lose all the edits, right? And also one more important is it is limited to 4,000 nodes per cluster. So Hadoop 1x is supported only 4,000 nodes. It will support only 4,000 nodes. So it will support only 4,000 nodes per cluster. It means in Hadoop 1x environment, so if you want to install 5,000 nodes, 5,000 data nodes in a cluster, that is not possible. So it means you need at least one cluster, you can install only 4,000 nodes. If you want to install remaining nodes, 1,000 nodes, you need to install a separate cluster. So it means single cluster cannot support more than 4,000 nodes. That is limited, right? So that is a drawbacks of storage layer in Hadoop 1x environment. Okay, so as of now we have discussed storage layer. Okay, so let us see some processing layer. What is processing layer in Hadoop 1x? Processing layer, we have two, right? Two layers. So in HDFS component, storage layer, processing layer. So now as of now we discuss storage layer. Now let us discuss processing layer. So processing layer, what is processing layer components? We have seen already. So processing layer components are job tracker, task tracker, right? So it is a programming model, processing layer, which independent of the programming languages. So we need to written programs in a separate languages. That languages we can see later, and that language types we'll call it as tools, ecosystem tools. Okay, so and it has two phases. The programming also two phases. One is map and second one is reduce. Okay, and also the components of processing layer, two components, job tracker, task tracker. You can see job tracker is a master, task tracker are slaves. Again here Hadoop 1x storage layer, name node is a master, data nodes are slaves. When coming to the processing layer, job tracker is a master, task tracker are slaves. Similar again, processing layer also, storage layer also, master and slave architecture, processing layer also, master and slave architecture, master slaves architecture, right? So we'll discuss later one by one. Okay, so let us see. Okay, so let me take a paint. So I'm going to draw processing layer now. You can see Hadoop 1x processing layer, Hadoop 1x processing layer. So we have master node. What is master node? Job tracker, right? So then task trackers. So one job tracker, so multiple task trackers, right? So here I can say it as job tracker, then task tracker. So I can simply say it as TT, task tracker. So TT stands for task tracker. So here when users are submitted a job, when user is submitted a job to the cluster, so first it will come to the job tracker, and job tracker will get the information where the files are available from the name node, and then it will divide it a job, then it will initiate a job, and it will go to the job tracker will assign a job to the respective task trackers where the data is available. So for example, if data is available here or here, wherever it is, so it will send the instructions to the task tracker, then task tracker will execute the job and send back the result to the job tracker. Then finally job tracker will send results to the client. This is processing layer theory, right? So here again job tracker is the master in the cluster environment. In the processing layer, task trackers are slaves. Okay, so if one task tracker goes down, we have multiple other task trackers. We can able to run the processing layer, right? So even if this task tracker also down, we have two more we can able to run. But job tracker down, what will happen? Again, job tracker is a master. What will happen if master goes down? Complete processing layer will be down. So we don't have any information about what are the jobs running in the cluster, because all the jobs information will be storing in job tracker, right? If job tracker goes down, job tracker machine or job tracker service goes down, what will happen? We will lose all the job status, right? But here, if you see, here client submitted a jobs are running, but where we can see the output? No, we cannot see, because job tracker is down. If job tracker is down, we cannot see any of the jobs, which job is submitted, which data node, we cannot see. That is the storage processing layer also defect for processing layer disadvantage. So here storage layer, processing layer, similar disadvantage like single point of failure in storage layer name node, processing layer job tracker, single point of failure. In Hadoop 1x, there is no other job tracker, only one job tracker, right? So this is Hadoop 1x processing layer. Okay, so now I will draw a picture, both written in a single diagram. Storage layer, processing layer. Now I connected with active master node to all the nodes. Okay, let me draw secondary name node as well. Okay, so now let me divide the nodes. Okay, so I can say this is name node, right? This is secondary name node, and this data node 1, data node 2, data node 3, data node 4, right? Similarly, this is storage layer, right? So here storage layer, right? So name node is a data node, name nodes are storage layer, storing the data. Similarly, I can say it, this is master as job tracker. What is this one? What I can say? Processing layer, right? Similarly, you can see these are task trackers. Task tracker 2, task tracker. Similarly, so now we can see complete diagram. Hadoop storage layer plus processing layer. Storage layer is a master in the name node and processing layer master job tracker. Again, data nodes, slave nodes, task tracker, slave trackers, right? Slave trackers in processing layer. Data nodes, slave nodes are in storage layer. Okay. Then, so if any of the reason, if one data node goes down, no problem. We have multiple data nodes, we can able to run the cluster successfully. But if any scenario, master goes down, either storage layer or processing layer, what will happen? Entire cluster is down. So if name node goes down on the storage layer, entire cluster down. If job tracker goes down on the processing layer, all the jobs, no, we cannot get the status, right? So here again, this is connected to secondary name node, right? So this is what biggest drawback in Hadoop 1x environment. What is that? So only one name node, okay, and also one job tracker. That means single point of failure in Hadoop 1x environment. If name node down or job tracker down, entire cluster will be down, right? So that is the scenario, like biggest drawback in Hadoop 1x environment. To overcome this drawback, they introduced one more name node in standby name node in Hadoop 2x environment. Hadoop 2x. So Hadoop 2x architecture is a separate different architecture. Okay, then we can discuss Hadoop 2x architecture further sessions separately. Okay, so as of now, we have done the Hadoop 1x architecture, storage layer, processing layer. Completely, we have completed for the development part. So Hadoop 2x architecture will start with separate session. Okay, thank you.